Section 26B, I called it. I think. Can you remember the last worksheet I gave you? I think I might have said A. I've got B on this worksheet, so we'll call it B. Let's make this a little bigger. And what we're going to do is we are going to solve, and I'll just write what this is called. We're going to solve by, and we're going to call this substitution. Now, we've done some substitution stuff before. We haven't done exactly this, I don't believe. Actually, tell you the truth, we may have done this before, but we did it with factoring. Yeah, I think we have done this before. Okay, but we did it with factoring, but now what we're going to do is we're actually going to solve for stuff. Do you remember this? Like if you had x squared, actually I don't need parentheses around that. Let me see if I can make one up off the top of my head. So, here, close your eyes, don't look at this. So, x plus 3, x minus, okay, let's alright, so watch if you had this, x squared minus 2x minus 15, okay? Remember having this kind of stuff? Now,
x plus 3x minus 5.
Yeah, see, I told you not to look. All right, so
that's just gonna make me want to look even more.
Yeah, I know. I was just kind of kidding. Well, anyway, let's take a look at this. Remember, back in the day, I can't remember, but it was early on in this class, we learned how to factor this stuff. Do you remember that? And then all you had to do was this. You had to go what? X minus 5x plus 3. Do you agree with that? Right, because that's negative 15, that's negative 2 when you add them up. But that was your answer right there. Okay, so there used to be a problem where we just said to factor, and that's all you had to do. But recently, what have we been doing? We haven't just been, oops, daisy, wrong tool, there we go. We haven't just been factoring, we've been doing what? Give you a big hint. Solving, right, we've been solving. So what was different about this when they asked you to solve? It wasn't just an expression. We call this an algebraic expression. It wasn't an expression. If we solved, you have to have a what in order to solve for it. You got to have it set equal to something. That's right. And we've always had these set equal to 0, haven't we? Okay, do you see the difference on what we did when we factored and what we're doing now? Now, we still have to factor, but the problem doesn't say factor. The problem now says solve. Yes? Okay. And then so what do we do with this? We set this equal to 0. Then you set them both equal to 0. Remember all that? All right, we'll just finish this up since we got it. So we went x minus 5 equals 0, and we went x plus 3 equals 0. We won't go through all the explanation for that, but that's what we did because we've talked about that before. Then you just solve for x, and x equals 5 and x equals negative 3. All right, so we actually solved for something. We actually got a value for x. And if you took this value for x and plugged it back into this, it would work. So let's just for fun, we got some time, let's throw this back in and see if it works. Let's put a 5 into this and see if it comes out to 0. Well, what's 5 squared? It's 25. Minus 2 times 5, which is 10. And then minus 15. 25 minus 10 is 15. 15 minus 15 is what? 0. So that works, doesn't it? All right, what about negative 3? How in the world can you have two different answers that actually work? All right, well, because of the square, that's the reason. So let's put a negative 3 in and see if it works. Negative 3 squared, which means negative 3 times negative 3, which is positive 9. Minus 2 times negative 3, which is negative 6, correct? All right, and then minus 15, and then let's see what that is. Well, that's 9 plus 6, which is 15, minus 15 is 0. So that works as well. It's all review, right? We've been doing that stuff recently, haven't we? And then I mean, that was like an easier version. Then we solved for x by completing the square. Then we learned how to solve for x by using what? We solved by factoring, then by completing the square, then by the Q. It's a huge hint, right? Because there's not that many words that start with Q. Quadratic formula, that's right. So we put in the quadratic formula. So we have several different ways we could have solved this thing. Agreed? But what I'm trying to get you to understand is that we've always been solving. We've always found what x is equal to. Right? So what we're going to do today is we're going to solve as well, but we're going to do a thing by substitution. Now, in the past, I can't remember exactly when, but we've actually factored things using substitution. And hopefully some of this will come back to you. So we're still going to do factoring like we've done. Like right here, we had to do factoring, didn't we? From there to there, we had to factor. but we also solved for x. So we're going to do some solve by substitution. So let's write down a problem, and let's jazz things up a little bit and go a different color here. Is that all right? All right, so let me find a good problem here. All right, here's a good one. Watch this. X to the fourth plus 2x squared minus 15 equals 0. All right. And the problem says to solve. But this might look a little familiar to you. I hope it looks a little familiar to you. Remember we talked, what looks familiar should just be this part right there. Because I've asked you in the past to solve for, or not to solve for it, but to factor this. And factor it by using substitution. But we are going to factor, but we're also going to set it equal to 0 and then solve for x. Okay? Remember what we did for this? It kind of looks like a quadratic equation, doesn't it? Very good. Actually, I'll tell you what, just to make this a little easier for us, let's use a different letter here instead of x. Sorry if you've already written that down. Let's just go a to the fourth and 2, oops, almost wrote x again, 2a squared. Is that all right? All right, Destiny said this. We said, instead of 2a squared, this would be a lot nicer if this was a what? An x, and this was a what? X squared, right? So what do? We say let x equal a squared. Is this coming back to you? All right, this is old stuff. It really is. Okay, if I don't know what lesson, you can look on YouTube and scroll through the different lessons in college algebra, and you can find the lesson where we talked about factoring
Somewhere
by
in
substitution.
chapter 1.
Was it chapter 1? Okay, I can't remember, but it's probably right. So we let x equal to a squared. So now what are we going to do? Well, let's rewrite this. Let's do the middle one first, because this is, instead of a squared, we said a squared was the same as x. Remember this? So let's put in what? 2x, right? And that minus 15, and that equals 0, stays the same. What about this thing right here? What's that going to be? It's going to be x squared. Very good. Because if I take x and square it, that would be a squared and square it. What am I going to get? A to the fourth, right? Isn't that the same thing? So by substitution, that's what we had. Again, I encourage you. I went into a little bit more detail when we taught this, when we taught the factoring part. Today is just kind of little reminders, all that is. So what we're going to do is, now this looks a lot better, doesn't it? That looks a lot more, quote, normal, right, than what we've, than factoring this thing right here. If you just try to factor this straight up, it'd be a little bit difficult. But by substitution, now we have something that we're used to, and now we can factor this. All right, so let's factor this. This is kind of like the same factoring I did earlier. It's just a coincidence. So we've got an x here and an x here. I've got a plus and a minus, and this time the 5 is positive and the what? 3 is negative. Everybody good with that? And now I can solve for what? For x, right? So I put x plus 5 equal to 0, and I put x minus 3 equal to 0. Now look, at this point, you might be able to skip this step right here, but I want to write it down just to remind you. That's how we solve for x. So if x plus 5 equals 0, then x equals negative 5, and if x minus 3 equals 0, then x equals positive 3. But that's not my answer, though, is it? Look at the problem. The problem said solve for this. So what am I solving for? Not x, but what? A, just A. I'm just solving for A in this. Well, I don't have what A is equal to yet, do I? So what am I going to do? Let's come back up here. What was x equal to? It was equal to a squared. So what do we put? Instead of x, we put a squared equals what? Negative 5. Good. And then over here, we put, instead of x equals 3, we substitute, right? Substitute back again. So this time we say a squared is equal to 3. Does that make sense on that substitution right there? Again, you don't circle the x's because that's not what we're trying to solve for. We're trying to solve for a. So we substituted it once, and then you substituted it back in, and basically we didn't really do anything, did we? All right, we substituted, and then we substituted back, and we're back to where we started, basically. So now we have a. So how do we solve for a here? Well, take the square root of both sides. So if I take the square root of this and put a plus or minus, since we're going to take the square root of it, what's this? Square root of negative 5.
square root of 5. I square root of 5.
Yeah, we can put an I in front and square root of 5 right there. Or you can put square root of 5I, but sometimes we don't do that because sometimes it looks like the I is inside the square root. So that's perfectly fine right there. Well, what else do we have to do? We got to solve for A right here too, don't we? So take the square root of both sides. So if I take the square root of this side, I get a plus or minus. Do I have to do an I thing here? No. All right, just keep it like that. So look what we have. We've got two answers here, don't we? Remember, there's two answers. There's a positive I squared of 5, and then there's a negative I squared of 5. Right here, we have a positive square root of 3 and a negative square root of 3. So there's actually, how many answers do we have altogether? 4 answers. Look at what we started with. We started with what? A to the 4th, didn't we? And guess how many answers we got? We got 4 answers, okay? Do you see a little pattern going on there? Okay, good. All right, we good with that? So really, this wasn't anything brand new. It really wasn't anything brand new at all. We already knew how to factor using substitution. The only thing different we did today was just solve for x. And we've done that before too, haven't we? All right. Now, remember I said the final is only going to cover the second semester, but you're still going to have to know a lot of the skills that you learned the first semester in order to do those problems in second semester. Everybody got that? Yeah, I think everybody understands that, right? Without me saying it anyway. But just thought I'd throw that out there. You want to try another one? There we go. We got a little response. Thank you, Morgan. Let's do this one. This is p plus 2, and that quantity is squared, minus 2 times the quantity p plus 2, and then minus 15. We're doing the same factoring. Guess I could have picked a different problem. But anyway, this is the one that popped into my head. This is the one that popped in my head. Well, actually, I just saw it in the book. So this is what we're going to do. And we're going to solve for p. Okay, it says solve, and that's what we're going to solve for. So over here, let's do this in a different color. Let's change this up a little bit. What are we going to do? We're going to let something equal something. We're going to let x equal. Now, what would I rather have x to be here? I want to substitute x in for something. Yeah, this whole p plus 2. Do you see it? This is kind of like x squared minus 2x, isn't it? All right, but instead of x, it's p plus 2. It'd be a lot easier to work with it if it was just one variable instead of the whole sum right here. So we're going to let x equal p plus 2. And then we're going to work it with an x, and then we're going to put that p plus 2 back in for the x. All right, so let's do this. Instead of p plus 2 squared, what did I say p plus 2 is equal to? It's equal to x. So instead of p plus 2 squared, it's what? It's x squared. Good. Minus 2, and then instead of times p plus 2, it's times x. Minus 15 equals 0. There's that factoring again. Now that looks a little more familiar, doesn't it? That looks a little easier to deal with. So let's go ahead and solve for it. Well, we got to factor first, correct? So put x here, put a plus and a minus. This time, the 5 is going to go with the negative, and the 3 is going to go with the positive. Sorry we're using the same numbers for all these factoring problems, but that's just how it worked out. I bet you can do the next step in your head, can't you? You know what you're going to do. You're going to go x plus 3 equals 0, so what's x going to equal? Negative 3, right. And if I go x minus 5 equals 0, x equals positive 5. Okay? And that's fine. You can skip from here to here if that makes sense to you. All right? We're not done, though. We don't circle that, do we? Because we're trying to solve for what? We're trying to, not just p plus 2, but for p. We're trying to solve for p, not p plus 2, but we're solving for p. So, we know what x is equal to. Well, look over here. If x is equal to p plus 2, what are we going to do? We're going to go p plus 2 equals what? Negative 3. And let's do the same thing over here. P plus 2 equals 5. And now we can solve for p. So you subtract 2 from both sides, and p is negative 5. Subtract 2 from both sides right here, and p is 3. We get 2 answers, don't we? We don't get any plus minus thing, do we? Because we're not taking the square root of anything. But we get 2 answers. Notice, this was quadratic, which means this was to the second power. How many answers do we get? We got 2 answers, didn't we? Okay, again, little pattern going on there, isn't there? Yeah. And that's it. If you wanted, you could check to see if it works. Let's just try one of them. Let's try the harder one, the -5. Let's put a -5. Let's just to see if it actually works, okay? If if all the stuff I was telling you about substitution is bogus or not. All right, I think it's going to work. Let's see. Put a -5. -5 plus 2 is -3. -3 squared is +9. Okay. Put a -5 in for this. -5 plus 2 is -3. -2 times -3 is yeah. I should have done +6, right? Because that'll come out to a +6, a +6. And then -15, that's 15 minus 15, and that does equal 0, and it works, doesn't it? Put a 3 back in here, that'll work as well. You can try that on your own. You okay with the substitution stuff? The substitution really seems to throw people for a loop a little bit until you start getting used to it. Once you start seeing it, then I don't think the substitution is so bad. Let's see. Let me look at your worksheet. Is there anything like real crazy? Yeah, let's do one with a negative exponent. Let me find one with a negative exponent. Here we go. Let's go with a little different color scheme. What color scheme do you like here? Come on, quick. Blue? Blue, and what other color do you want to use? Orange? I heard orange first. We use orange. Alright, so 7p to the -2nd. This time we got some negative exponents. And the factoring's not quite so easy here. In fact, I don't even know if it factors or not. It might. But it looks a little bit weird. Look at this crazy thing. It almost looks like a quadratic, doesn't it? It kind of looks like 7p squared, but it's not squared. It's to the what? It's to the -2nd power. So we're going to have to do something. We're going to have to do some substitution, would be my guess. Wouldn't it be yours? Since that's what we've been talking about all day? Yeah, so what are we going to do? We're going to say let x equal. What do we let x equal? This middle one right here, right? That's what we've always been letting x equal. So let x equal what? P to the -1st. Alright? Because it's not p to the 1st, is it? So I can't just factor it or solve for it the way it is right now. Oh, by the way, I should do this. This equals 0. Let's do this. Let's -6 what? Equals 0. So I had to, I forgot about that. But I think that's pretty important. Alright? Everybody see that? I hope you do. Because it's kind of like 7p squared plus 19p minus 6 equals 0. But it's not just a p squared. It's not just a p to the 1st. It's p to the -1st. So what am I going to have to do? I'm going to do some substitution and make that into an x. So if I do that, what do I get here? This is going to be 7x squared plus 19. What do we make x? Or what do we make p to the -1st? We made it an x. That's going to be an x. Minus 6 equals 0. You could try to see if this factors. Let's just try it. There's probably not too many choices. 7x and... Oh, I'm sorry. We don't want to go 7. What do we want to do? Yeah, we do. I'm sorry. 7x and 1x. And then one's going to be plus, one's going to be minus. I don't know. What do you want to try? 3 and 2? Let's try 3 and 2. Let's see if that works. That's -14 plus 3. Nope, that's not 19. Let's do this. Let's just switch the... You want to try... What's that? You can't do 4 and 3. It's got to multiply to be... You can go 6 and 1. You want to go 6 and 1? Let's see if that works. That's -7 plus 6. No, that's not going to work. What if we change the 6 and the 1 around? Maybe 1 here and a 6 here. That's -42. No, that's not going to work. There may not be anything that works here. What was the other thing? We went 3 and 2 before, didn't we? Did we go 2 and 3? It's -21. I think I might be getting somewhere. It's getting closer because that's -21 and that's plus 2. That's -19. So let's try this. Let's try switching the signs, right? So what's that? That's +21. It does factor, doesn't it? All right. Shoot, by the time you did all that, you might have just done the quadratic formula and got the answer by then. But you might have guessed that right off the bat too. You might have gone, with those numbers. Who knows? But we figured it out. You understand what I was trying to do here? I know I went a little quick and I wasn't really explaining myself. But if I do the first, that's +21. If I do the I'm sorry, the outside and inside. The outside is positive 21, and the inside is negative 2, or yeah, negative 2, which is positive 19, and that's what I wanted. So that does factor. So good thing we tried it. So what do we do to solve for x now? We set them equal to 0. Alright, so if we set this equal to 0, if we add a 2, and then we divide by 7, so that's 2 over 7. So I'll just write that down. X equals 2 over 7. Then this is pretty easy to do. Subtract 3 from both sides, and x equals negative 3. Are we done, though? Is that our answer? No, it's not our answer. It's what x is, but now we got to substitute back in, correct? Keep everything on this one page right here. So x is 2/7. So look what we're going to do. X is the same as p to the negative first. So instead of x equals 2/7, we're going to say p to the negative first equals 2/7. Hope you see that, right? Because x and p to the negative first are the same thing. So instead of saying x equals this, right, we cross that out. Actually, it looks like an x, doesn't it? Okay, we scribble that out and we say, let's make it p to the negative first equals 2/7. We good with that? Let's scooch this over a little bit. Give myself some room. And then, what else do? We go p to the negative, instead of x equals negative 3, we go p to the negative first equals negative 3. Again, we substituted p to the negative first back in for the x, since we set them equal to each other up here. Now, what in the world do we do here? How do we solve for p? I know p to the negative first equals 2/7, or yeah, but how do we solve just for p? Well, I'll show you what we do.
P to the first?
Trying to think of the best way to explain it. Yeah, we do want to make it p to the first, but how do we get rid of this p to the negative first? There's a couple ways you could look at it. You could take this thing to the negative first power, couldn't you? Because what if you did that? What's p to the negative first to the negative first? P to the first, isn't it? Okay, but if I take this to the negative first, what am I going to have to do over here? Take that to the negative first, okay? Everybody see that? Or I could have looked at it like this. So here's another way I could have looked at it. P to the negative first is the same thing as 1 over p. Would you agree? Equals 2/7. I don't know which one's easier for you or not. You get the same answer. Because what's 2/7 to the negative first? What does that mean you do? It means you just flip the fraction. That's right. Look at this. I want to solve for p, right? So how do I solve for p? Flip this, and I got to flip this. Right? You get the same answer either way, right? So what is p then? P is 7 over 2. So that's one of my answers. So that was a little weird, wasn't it? Now you get the idea. Now you should know what to do here. Watch this. So put this over 1, because we know we're going to flip, right? Because p to the negative first, how do I get a p out of that? Well, I just flip it, right? That's p to the first. If I flip this, I got to flip this. So what do I get here? Just negative 1/3. And that would be your answer. Still negative, because basically I did this. I took that to the negative first, and I took this to the negative first. Again, what do you do with a fraction when you take it to the negative first? All you do is just flip it. Your sign still stayed there, okay? That negative didn't go away. It's not negative times negative is positive. A lot of people get confused on that. Okay, this negative exponent, this negative first, the only thing it tells you to do with this fraction is just flip the fraction. You still keep the negative. You just flip the fraction. And those are your two answers. So aren't you glad we did that one? Yeah, because I doubt you would have done that one on your own. You think? So now you see it though, right? All right. Well, I think we pretty much hit all the kind of stuff in here. There's one with a fraction exponent. Let me see if I can find. We'll do that super quick. If I can find one in the book. All right, let's do this one really fast. We got 5 minutes. So, what do you want, Morgan? Purple? They call that raspberry. Is raspberry okay? Okay. So I'm going to do this a little.
I prefer strawberry.
I don't know if they have a strawberry.
Or cotton candy.
Yeah, but cotton candy can be all kinds of colors, couldn't it? talking colors, not flavors. Alright, here we go. Look at this crazy thing. And what do they tell you to do?
Jane, get
Solve.
me off this crazy thing.
Alright. What's the reference for that?
Jetsons.
Oh, the Jetsons, right, of course. I should know. I grew up with the Jetsons. Alright, I know exactly what you're talking about. Anybody else know what she's talking about? Anybody watch the Jetsons? You guys? Yeah. Right, in the beginning of the show, right, what are they on, like a treadmill? Oh, it was that dog walk thing. Yeah, it was like a treadmill though, wasn't it?
Yeah.
Yeah, exactly. Alright, let's do this real quick. We're running out of time. So what are we going to do? We're going to let x equal y plus 3 to the 1/3. Yeah, so we're going to let x equal that whole entire thing right there. Everybody see that? That's going to be the x. So what happens? Well, this is to the 2/3, which means it's to the second power. So this is going to be x squared. This is minus 2x. This is minus 3 equals 0. And let's just solve for x now. So this should be an easy factoring. So it's negative 3 and what? Plus 1, right? They multiply to be negative 3 and they add up to be negative 2. So that means x equals 3 and x equals negative 1. Alright, that was pretty simple. I think we all got that. As long as you get the substitution, solving for x wasn't that big of a deal. So now what do we do? Let's go back to the purple now since we're doing the y's. So instead of x equals 3, we're going to do this. We're going to go y plus 3 to the 1/3 equals 3. See that? I just substituted x for what x is equal to. Then I'm going to do the same thing over here. Give myself a little room. So y plus 3 to the 1/3 is also equal to negative 1. Just substituted it back in for this. And now we have to solve. To the 1/3 power. Well, how do we get rid of a 1/3 power? Well, we take it to the third, not square it. Square's not going to get rid of a 1/3. Okay, we have to take it to the third power because 1/3 times 3 is a 1. So we have to take that to the third power. So let's see what happens. Look, that cubed and that cube root basically got rid of each other. So I've got y plus 3 equals 3 cubed, which is 27. Subtract 3 from both sides and y is 24. Do the same thing over here. We're going to take this to the third power and we're going to take this to the third power. So this third power cancels out with that 1/3 power. I've got y plus 3 equals negative 1 to the third. It's negative 1 times negative 1 times negative 1, which is negative 1. It doesn't cancel out the negative there. And now we subtract 3 from both sides, and y equals negative 4. And there's your answer. So it looked really ugly at the beginning, didn't it? It looked nasty ugly at the beginning. All right? But we tamed it, didn't we? We made it look a lot better by substituting something that we're more familiar with, just a regular x, in for this stuff. Once we got x in there, then it was really simple. Got a little bit harder when we substituted back in, but now you know what to do. If it's to the 1/3, you take it to the third to get rid of it, and then the rest wasn't that bad at all. Those are your answers. All right, let me give you a worksheet. Look, I haven't given you homework in almost 2 weeks now. Do you agree? Because we took a whole week to review. I didn't give you any homework. And then last week you had midterms. I didn't give you any homework. So there should be no complaining this week. Sorry. This week or this past week. So anyway, there should be no complaining, right? You should be grateful that you have math to do to get your brain working again. Are you not grateful? I don't blame you, but that's okay. No, you can keep your test. I don't give 2 points on the midterm to get it signed because that goes on a marking period grade. But just put it on your fridge, and whether you did good or whether you did well or if you did poorly. If you did well, it gives you something to look at and be proud of. If you did poor, it gives you motivation to do better next time, right?